VinFuture Prize, a new global science and technology prize for humanity from Vietnam. One VinFuture Grand Prize of $3 million. 3 additional special VinFuture prizes valued at $500,000 each. VinFuture Prize honors science and technology work that creates or has a high potential to create meaningful change in the everyday lives of millions of people. Join us to make a change for a better future.
Greetings everyone, esteemed colleagues joining us from all over the world. On behalf of the VinFuture Foundation, I want to extend a warm welcome to all the audience of the second InnovaTalk Webinar of 2024. I'm Vizung, and it's my pleasure to be your moderator today. Now, we will embark on the captivating explorations of the topic, Generative AI, Breakthroughs and Challenge. These pivotal topics compel us to dive into the vanguards of advancement in AI while also thoughtfully considering the challenge it presents. Guiding us in these insightful discussions, we are fortunate to have a distinguished panel of experts. First, let me introduce Dr. Shredong Huang, Chief Technology Officer of Zoom Video Communications, member of VinFuture Prize Council, former Microsoft Technical Fellow and Azure AI Chief Technology Officer, overseeing engineering and research. We are also immensely honored to have 2 leading figures in the field of AI joining us as our distinguished speakers. Dr. Eric Horvitz, Chief Scientific Officer at Microsoft. He has been elected to the U.S. National Academy of Engineering and was formerly appointed as a Commissioner of the National Security Commission on AI, sharing the light of effort on ethical and trustworthy AI. Dr. Alex Ratner, the co-founder and CEO at Snorkel AI, an affiliate assistant professor of computer science at the University of Washington. And last but not least, our special guest for today's webinar, Associate Professor Lê Hoàng Sơn, Vice Director of VNU Information Technology Institute, Vietnam National University, Hanoi. He's a consultant of Vietnam Government Office from 2019 and is one of the 2 Vietnamese scientists in the list of top 100,000 leading scientists in the world with the greatest influence for 5 consecutive years from 2019 to 2023. Before we delve into the heart of our discussions, I would like to invite you to immerse yourself in the trailer of today's webinar. This captivating piece will offer a glimpse into the topic we will explore, setting the stage for an exceptional discussion.
The 21st century witnessed an outburst in AI development in both research and mass application. Generative AI is the game changer we've been waiting for. From generating new ideas to creating visuals, composing music, and even developing new software, AI is pushing boundaries like never before. Businesses now leverage AI as a tactic and a tool to innovate faster and smarter. Personalized automated content creation and advanced problem solving is just the beginning. Whether it is a tech enthusiast, an entrepreneur, or a solo creator, generative AI is opening doors to a plethora of new possibilities. Generative AI is the 4th industrial revolution. And to give us more insights into this exciting field, this July, VinFuture brings you the InnovaTalk Webinar, Generative AI Breakthroughs and Challenges, moderated by Dr. Shredong Huang, Chief Technology Officer of Zoom Video Communications and also member of the VinFuture Prize Council. Dr. Huang has over 30 years of experience in computer science and artificial intelligence, in which he laid the basic groundwork for spoken language processing (SLP) for machine learning systems, as well as other core AI functionalities like speech recognition, natural language processing, and computer vision from a very early stage. Next, we are honored to welcome our first distinguished speaker, Dr. Eric Horvitz, Chief Scientific Officer at Microsoft, who stands as a paragon of expertise in artificial intelligence. He leads strategic initiatives at the intersection of the sciences, technology, and society, including frontier efforts in AI and the biosciences. Also on this powerhouse panel is Dr. Alex Ratner, the co-founder and CEO of Snorkel AI. At Snorkel AI, Dr. Ratner helps lead the development of a new programmatic AI data labeling and training datasets management platform, allowing leading organizations worldwide to build robust machine learning models quickly and cost-effectively. Representing the Vietnamese AI researcher community is Associate Professor Le Hong Son, Vice Director of VNU Information Technology Institute, Vietnam National University, Hanoi. His main research areas include soft computing foundation, knowledge-based systems, integrated machine learning for multimedia intelligence, multimodal environmental AI, with an interest in applications in medical imaging and mega recommender systems. With these exceptional speakers, we are excited to invite you to this InnovaTalk webinar. Join us on this journey as we uncover the breakthroughs as well as the boundaries of generative AI in this new era.
Now, it's my privilege to introduce the person who will be leading our discussion today, Dr. Xuedong Huang. Dr. Huang is currently the Chief Technology Officer of Zoom Video Communications, member of the VinFuture Prize Council, former Microsoft Technical Fellow, and Azure AI Chief Technology Officer. Dr. Huang, I'm turning things over to you. We are all eager to hear your insights and guidance as we explore the exciting world of generative AI.
Okay, thank you. Thank you, VinFuture Foundation, for giving us this opportunity to get together to share our learning challenges facing the whole society. So generative AI is indeed a very exciting moving force. This is going to help improve productivity for all walks of life. If you look at the history in the last a few thousand years, the first industrial revolution, steam engine, really lifted the worldwide productivity. And the second one, third one, also amplified, driving exponential growth of the productivity of everyone on this planet. Now, this is the most exciting time. It took less than 3 months for ChatGPT to reach 100 million users. It took more than 15 years for mobile phone to reach the same level of active users. You can see the revolution and the speed. We are honored to have our, really world-class AI leaders, practitioners today in this panel. So I will just actually give the stage to my dear friend, Eric Horowitz, who is the Chief Scientific Officer at Microsoft. Eric, the stage is all yours now.
Well, thank you very much, XT, as we call you at Microsoft over the years. Let me now display some slides and we'll just get into the presentation here. So it's great to be here with you all today. It's such an exciting time for AI, as XT mentioned. AI is going to be considered for hundreds of years to come a major technical leap for humanity. We've seen an incredible acceleration in capabilities over the last 20 years, and these technologies are now poised to influence many areas of our lives, education, healthcare, and the sciences. Given my sense for where things are going, I believe that 500 years from now, the next 50 years will be remembered as a significant time of an upswing in AI innovation and influence, and the period of time will actually likely be specially named. Now, we're at an inflection point in AI. We've been riding on top of a fast-moving wave of innovation with deep neural network models for nearly 15 years. And that wave has included reaching parity with humans on a number of challenging benchmarks in visual and language tasks. But over the last 3 years, we've been riding on yet another acceleration that I see as an inflection upon an inflection with the qualitative and quantitative capabilities we're now seeing with generative AI that show unexpected powers of generation, synthesis, and composition. Many folks' first exposure to these powers came via image synthesis. When DALL-E 2 came out from OpenAI, I was working on a project to build a pool, and I wondered about, could I have solar power as well as solar water heaters? Could I combine these things together? And just was amazing to see the compositional abilities of these systems to create creations, build creations that had never been created before. But soon after those kinds of systems were out in the visual space, powers of generation were demonstrated for computer programming. One of the earliest huge commercial successes of generative AI was GitHub Copilot, which continues to generate guesses of the next portions of programming code that a software engineer may find useful. Now, GitHub Copilot today plays a significant role in the daily life of millions of software engineers. Studies have demonstrated that the tool increases productivity by over 50%. But I've been particularly excited about interesting and mysterious emergent capabilities we're seeing with scale of the data and compute. Indeed, the headline over the last 18 months has been the qualitative and quantitative capabilities we're seeing with generative models that come with scale. Here's the data center where GPT-4 was birthed, just west of Des Moines, Iowa, that provides 10,000 top-line GPUs and 300,000 CPUs. While some improvements were expected, others are surprising. Studies demonstrate the fast rise of capabilities in language, mathematics, and programming tasks. And with the emergence of surprising abilities like learning to solve a new task from a handful of examples in a single interaction. Now, in the fall of 2022, our team gained access to test GPT-4 for studies of both safety and capabilities. We were surprised by the general purpose powers of the model. For example, showing the ability to write a proof of the infinitude of primes as a poem, or to write computer programs in response to a prompt without specialized tuning. Now, it's still early days, but I see the rise of powerful automated reasoning capabilities and interesting and shared methods and pipelines being developed across multiple disciplines and challenge problems. I'm particularly optimistic about the possibilities ahead for harnessing AI to help scientists and engineers to make significant progress on global challenges. Long-standing grand challenges of what might be possible in areas spanning health and life sciences, material science, agriculture, sustainability and climate science, the social sciences, and education. So I'd like to turn just to a couple of examples right now for harnessing the rising powers of AI to solve grand challenges in the realm of scientific discovery. Now, AI is still in the early days of helping scientists with modeling and reasoning, and with performing discovery at multiple spatial and temporal scales. But models are under development now for spatial scales ranging from atoms to compounds, and from gene expression and protein interactions to cellular networks, from cells to physiology, and from individuals to populations. A constellation of AI methods are showing promise for helping to supercharge what I would call core components of scientific discovery, including generating and identifying candidate solutions, accelerating and enhancing scientific models and simulations, analyzing new types of data, bridging the in silico, the computer world, with the natural world to guide experimentation, and perhaps most importantly, to come up with new mechanisms and provide new insights. I'd like to give you a few examples that highlight the possibilities. The first is in the realm of material science, the area of science and technology that provides us with novel substances and materials. Materials are central in our lives, and we even name different eras of our civilization by them: Stone Age, Bronze Age, Iron Age. Now, AI methods have been used to predict millions of new stable materials, and AI pipelines have been created that can help us define new materials and to discover them. The grand challenges are ahead that include developing new materials to store energy, new catalysts, room temperature superconductivity. Now, properties of materials are largely defined by complex interactions among the electron shells of molecules. And best understandings we have of electron locations and interactions comes via Schrodinger's equation, which is an equation from physics which dictates the distribution of where electrons are in atoms as they interact with one another. Solving the equation is exponential in the number of electrons, which makes its direct use very difficult in searching through massive numbers of possible new compounds. However, approximate methods have been developed, and recently AI models have been built to serve as Schrodinger simulators of sorts. They're trained via more complex computations, classic computations on samples, and And while they're somewhat expensive to build, once built, these models can be used to make predictions thousands of times faster than the base level computations. And these approximations are being used now in workflows. And we're even thinking about building science foundation models that can be used, that can have multiple forms of multimodal or different types of scientific information inside of them to use in multiple types of studies. Here's a quick example of an AI-centric discovery pipeline, a recent collaboration between the Pacific Northwest National Laboratory and Microsoft. We harnessed a discovery pipeline to find a promising new electrolyte candidate for a battery that requires 70% less lithium than today's batteries. The pipeline employs several distinct phases of AI models as well as high-performance computing to first generate a list of 32 million possibilities for a new electrolyte for a battery, then to narrow it down to 500,000 stable materials, then further focus down to 18 new candidates. And in the end, a single solution was identified, synthesized, and tested. So components of that discovery pipeline operated at speeds thousands of times faster than traditional methods. The team estimates that the same result would have taken 20 years and nearly $2 billion with traditional methods. But with AI systems and a new pipeline, AI models, the cost was about $350,000, and this took about 80 hours, 2,000 times faster than it would have taken. So I'm going to stop here, but to say that we have other examples that are as powerful and as deep, including AI in the health and life sciences, for looking at forming new computational microscopes to understand structure, to predict and understand various kinds of metabolic lesions, as well as genomic lesions, to predict how proteins interact, even identifying unknown functions that we haven't seen before that raise new questions, and to even design new proteins and structures. So I'm very excited about where we're heading as we move into the future. And we already see very similar pipelines that we saw in material science, for example, discovering new antibiotics that have really recently come to the fore, like the new antibiotic halicin, which was discovered through AI pipelines. These new antibiotics are discovered in spaces that we can visualize through AI methods that show us pathways to fighting infections that have become drug resistant over the years. So with that, I'll stop there just to say that I'm very excited about the future and where things are going, and we can maybe take things to question and answers. I want to stay on time. There's a lot more to say, and I wish I had more than 15 minutes, but I didn't want to sort of go over my allotted time today.
That's a great talk. Really, as Eric summarized, AI is making a huge impact to material, healthcare, discovery of drug, of course, productivity. So, but AI without data will not be AI. This is like the oil for the engine. So it's my great honor to have our next panelist, Alex Redner, co-founder and the CEO of Snorkel AI. Alex? All right. Thank you.
Well, XD, thank you so much. And thank you so much to the VinFuture Prize Foundation. It's such an incredible mission, and I'm humbled to be here. Eric, you set the bar incredibly high as an opening act. As XD teed up so well, you know, it almost sounds tautological to say that data is important to AI, because of course, when we say AI, we mostly mean machine learning based methods, you know, learned AI algorithms and models from data. But what I'm going to talk about today, and I'm going to bring in some of the field perspective, you know, from some of the large enterprises we work with as a platform developer, as well as wearing my academic hat from work at the Stanford lab and then at UW, is really what goes into refining that oil, as you said, XD. What goes into the labeling, the curation, the development of data to make it AI ready as many are now talking about. And to get from that proverbial 80%, the foundations, we like that phrase foundation model too, where you have these very powerful models. Think of them like we've jumped from AI as infants to AI as very smart college graduates. How do we turn those into onboarded, highly trained specialists for critical use cases in large enterprises and organizations? And I'll argue that the key is the quality and the specificity of the data that you feed in, how you curate and label and develop it. And I'll give a little bit of an insight into how we're trying to enable folks to do that more efficiently. So let me go ahead and share my screen. So I'll try to structure this. I'm going to get a little bit in the weeds here. Again, a lot of my activity is taken up actually trying to build a platform that we serve to enterprise customers, including 7 of the top 10 US banks and others globally across a bunch of different verticals. Healthcare, like Memorial Sloan Kettering, insurance, telecommunications, et cetera. I'll try to stay high level, though, at the start in framing this. And I'll try to be a little bit provocative for discussion, because I think a lot of the magic and excitement of modern large language models or foundation models is that they can do so much out of the box, so to speak. And they truly are a massive, order of magnitude leap forward in our foundations. I'm going to try to provide some of the perspective of how do we get them, the last mile across the finish line in these specialized critical enterprise settings, whether it be making a judgment at a hospital or classifying fraud at a bank. 3 key takeaways I'll illustrate here, or argue for here. One is that the out-of-the-box large language models that have been pre-trained and perhaps tuned on generic internet data and according to generic objectives and policies generally need to be specialized in some form for these critical enterprise tasks. Number 2, the main tool for doing this, the main programming interface for these AI models these days, if you will, is the data that's put in, whether it's into to prompting them or tuning them or aligning them, different terms we use. It's all about this data. And number 3, this is getting a little closer to the pitch of what the Snorkel company does and what the Snorkel line of research does, so I'll keep it minimal. But we generally think, not specifically talking about any one technique, that if you believe my first 2 points, that data is the effective programming language for AI models as they get more black box and standardized in many ways, that development of this data has to become more programmatic, like software development. And I'll talk a little bit about our public research as well as productization efforts there. So on the first point, one perspective that we see in the field is that there's effectively 2 waves of AI use cases from one perspective. And the first wave is where you can take an off-the-shelf large language model that's been trained on the vast quantity of internet data against, shockingly general objectives, right? Just look at some sentences and predict the next set of sentences, and out of it come all these emergent multitask capabilities. We see that these use cases are providing immediate value in settings that are a little bit more domain general, and that have a little bit more flex around what the accuracy is. So code copilots, we use them at our company, and there's been massive success there. Actually, a great example. Programming is a extremely difficult and highly paid task, as many of us know. But in some ways, it's an easier target to start providing value because many programming languages are shared across companies. Very few companies have their own proprietary programming languages. And coding copilots can start providing value, even if they don't have a measurable accuracy or a perfect accuracy. As long as they provide some measure of helpful suggestions and efficiency gains, they can start being used. Now, I'd argue that there's kind of a second wave of use cases where the data and requirements are very domain or enterprise specific, and the accuracy requirements are extremely high. Some of these tasks may seem more mundane. Think about classifying whether a customer is upset at a bank about a specific issue, but they might carry multi-billion-dollar fines for any accuracy, any inaccuracies. and they might be very specific to the domain and the organizational policies. And this is where we think that just like you'd have to onboard even the smartest college graduate to your organization before you trust them with these use cases, large language models, AI models, need to effectively be onboarded or specialized to perform well here. And I feel like I'm kind of almost betraying my academic background by quoting Gartner on something, as much as we love them, but I will nonetheless, as a barometer for how industry is seeing this and experiencing it. There's a broad consensus that a large portion of the models that are deployed in these kind of wave 2 use cases are going to be specialized variants of AI models. They're going to be specific buildings and structures constructed on top of those foundations, rather than just the generic foundations themselves. So we think it's not an either or, but we think there's a lot of the world of use cases that are going to be built on top of specialized AI models. And the second point, so I'll get successively more narrow and maybe controversial, but is that not only one of the most important tools, but increasingly the only tool for most practitioners to do this is by curating, selecting, filtering, and annotating the data they feed in. Let's go back to that simple analogy that I like of a college new grad who you're trying to turn into an oncologist or a fraud expert or a network engineer. You don't generally train them to become a specialist by performing brain surgery. You give them a curated curriculum of data, of examples of how to perform a task, of manuals and guidelines. And I'd argue we're seeing a similar transformation or evolution in AI, where we used to be, AI, ML, the courses we taught, the courses that I learned were all about that brain surgery, those algorithmic and model-based or model architecture-based edits you'd make to get something to work. Today, models are massive, and they're standardizing in an incredible way around common architectures. So arguably, the main tool is the data you feed in, just like in the human analogy. So this is where I might get a little in the weeds, but also this stuff is out there quite a bit. So I'll go a click deeper and talk about a common architecture that we often see. So a lot of the LLM systems or the AI model systems that are moving into production have 3 basic components, and many of you have probably heard these buzzwords far too many times. But just like a human expert would need, they generally need some kind of context. They need to be able to read the documents in the organization or look up the knowledge base or query the database. And generally, we've started calling that retrieval augmented generation, meaning pulling some contextual data to better inform the response of the AI model or the large language model. Then once that context is retrieved, there's actual generation, and then there's some step of evaluation, which is critical. Now, this architecture is going to evolve. It'll have more links and dynamically determined links in the agentic future pathways. Retrieval augmented generation will get absorbed into long context models in certain settings. Lots of variants, but this is just an architecture that we often see, and buzzwords that many of you, even if you're not deep in the weeds, have probably heard about. One diagram, I think I'm taking this from an OpenAI presentation, I believe that's the proper attribution, is kind of talking about the tools of the trade. How do you get the system to work? How do you teach that college student to become that oncologist or legal or insurance expert? And it kind of breaks it apart into different tools. You have to potentially, you start by prompting, meaning kind of telling the student what to do. Then you move, if the performance is not good enough, to fine-tuning, meaning giving lots of examples, labeled examples of the correct behavior, and actually the model learns, updates its weights, much like a college student would learn from experience how to become a doctor. And then in some cases, no matter how smart that model is, it needs better context. Just like no matter how smart the doctor is, they might be the world's best oncologist. If they can't look up the patient's chart, they can't make accurate judgments. So there is where you have to move to context optimization and improve what data is being fed into the system. And that's often referred to as RAG. So I'd argue that after a certain point, all of those directions of improvement end up requiring high quality data, at least in the use cases where every accuracy point really matters and you need high performance. So, going a step deeper there, how do we actually improve these steps? How do we teach models? And you don't need to pay attention to every term here, but just at a high level, a lot of these steps are improved via labeled data or labeled examples that teach the model system or the system components to do better. For retrieval, take a step back and imagine how you might teach a new college grad to better query the medical literature. You'd probably give them examples of how to search it properly. And indeed, one of the most powerful ways that we've found in practice and seen from others to improve the retrieval step, and this has widely been or been reported in the literature for a long time, ever since the original RAG paper and all the way back to classic information retrieval theory, or not theory, just information retrieval practice, is you tune the models that are doing the retrieval. And how do you tune them? You provide them examples of here's the query and here's the right bit of context to pull out. And indeed, that can yield big gains. When it comes to generation, again, go back to that simple analogy. How do you teach the young medical student to make better judgments? You give them highly curated and relevant examples. And this is, again, where we see massive gains coming from fine-tuning, reinforcement, learning from human feedback, other approaches, which I'd argue are converging. You're basically just giving the model examples or feedback or both to learn from, just like you would with a human trainee. And then, of course, evaluation. We see lots of stuff around automatic evaluations, but in these kinds of high accuracy domain-specific settings, usually enterprises won't deploy a model until they can have their own trusted experts actually go through and label data and give human feedback. So in all these steps that are so critical, I'd argue one of the key ingredients, one of the key pieces of fuel is carefully labeled, curated data. So I've already failed the test of meeting Dr. Horowitz's timeliness, so I'm going to admit defeat there, but I will move quickly through the last 2 minutes and just give some examples and stories. So just to give some examples from data in the field, and there's academic examples too, but I thought I'd share some that are not published yet from real customer case studies. Example from a top 10 US bank, customer of ours through the company. This was a CIO-sponsored effort to build a chatbot over complex legal documents. This got shown all the way to the CEO of the bank, amazing demo, but when they tested it on a certain subset of use cases, it was getting 25% accuracy. Most of that error mode was because it was failing to retrieve the context from these multi-hundred-page legal PDFs. So by tuning the RAG system with labeled data, we were able to get it up to, actually it's in the 90s now, 90, 94, 95. Similarly, with a top 5 telecom customer of ours, this is still climbing, but most recently we achieved a 17-point gain by creating better labeled examples to learn from. Just like you'd imagine a customer service rep would learn from better examples from the training manager, same thing here. And evaluation, similar gain. So I'm running out of time, but I'll just note 3 things that make data curation and labeling interesting and challenging today. One is that most of the areas where models still need tuning, where they don't have the baked-in knowledge, are precisely those areas where you need specialized experts and specialized data that's not on the internet, which makes it very challenging and expensive. Second, objectives are changing all the time. And 3, it's a quality over quantity world. And I'll just note to wrap up one cool study I'm excited about that is public. This was called the Datacomp benchmark. It's at datacomp.ai. And it's set up as a contest where we fix the model and we fix the algorithm for a foundation model, a multimodal one. And we just let participants curate the data. And by curating the data, filtering and sampling better, higher quality data, we beat all of the public models at compute parity. So it just goes to show you that if you hold everything constant, the ingredients, the fuel, the quality and specificity that you put in is one of the great determiners of success in AI at all stages these days. So I'll wrap there, and thank you for the time.
Thank you, Alex. That's perfect timing. You just used up your time precisely without wasting a second. What to the point is really data. What Alex shared is what the industry is facing, the real challenge, how to get a curated high quality data. We determine how AI can land to be used in all walks of life. So thank you, Alex, for the great sharing. Now, last but not least, AI is not just a US phenomenon, right? Every corner of the world, whether it's in Europe, US, or Vietnam, you can see we have great research and technology companies, universities, embrace generative AI and push the frontier. Now it's my great honor to have Professor Lao Hong Song to share his experience in Vietnam.
Okay, so thank you, Dr. Huang. So thank you, VinFuture Foundation, to let me introduce some things about remarkable achievement of Vietnam scientists through generative AI. So let me share my screen. Okay. So as already introduced by Dr. Aris and Dr. Alex. So as you know that generative AI is not new. It's especially that is already introduced in 1960 for some chatbot application, but in fact, it's not create a good outcome and a good result. So actually, that it last 10 years in 2014 with introduction of GAN networks. So it's booming with a combination between some data sets like image, text, audio, video to generate some output in a good manner. So here I just have some make reviews of some cycle for AI in 2023, and you can see in that Hunter placed the generative AI in the top of big inference expectation, and as you can see that it has a lot of good fortune model like stable Llama language models and stable Falcon, Mistral, deploy, and stable Vision. But as already I note that there's a gap of a year between 1 or 2 years between the technology in the world and the technology in Vietnam. So some type of technologies, for example, here more model operations, edge AI, and rice graph would be still to create a new opportunity for innovation in Vietnam. Here in Vietnam, I just have to make a few overview of generative AI readiness in Vietnam. So I can see that in Vietnam, AI technology is mostly used for some customer care service, especially in the banking sector and insurance. So especially in Vietnam, our government have some policy to foster the development of AI and digital transformations in Vietnam until 2030. So when I remember in last year, when the OpenAI has not been allowed a ChatGPT registration in Vietnam, most of the people were trying to create accounts to access the chatbot. So in many universities, ChatGPT was used by most of the teacher and students to assist with teaching and learning. So I can see that now in the next 5 years, I think that the most government will be make a bigger investment in AI, in an automation rather than investment in human resources. And here we also have the motivation from the chatbot. Currently that we have with many companies, for example, Viettel Cyberspace, Annex, and both Bán Hàng. This is driven by several key factors to make the need for ChatGPT or a chatbot in healthcare, in government, in e-commerce. So it is some of the key players like that make a motivation for the development of the generative AI in Vietnam. And we also have the motivation from the government. It also another factor. Our government considers that the AI technology and some type of related products to be the more motivation for directing the economics and social development in the AI in Vietnam in the next 10 years. So by the 2030s, our government wish to be one of the top 4 nations in ASEAN and among the top 50 countries in the world in terms of AI research, development, and technology. So our target in a Ministry of Information and Communication to aim to make 10 national AI products in terms of some fields like medicines, healthcare, and environments, and so on. So I think that this will bring a good opportunity for researcher and industry and community to focus on AI, and especially in generative AI. And we here is a little bit introduce the component of the generative AI, especially in multimodal datasets, and three basic component in GAN, the rational algebraic encoder. So as already introduced by Dr. Alex, so I will not go into detail of this technique, but this component make much important to the development of generative AI in Vietnam in many years. So in this, I'm just have introduced the first attempt of Vietnamese researcher to generative AI. As you know that generative AI has a they said they try to make a pre-trained model in English or in many language to Vietnamese language. So the first attempt of the Vietnamese researcher is to create a various data sets. Like you see that data sets with LM with retrieval augmented operations. You see the picture here, the data sets for machine reading and data sets for multiple choice machine readings. And we also have the Association for Vietnamese Language Speech Processing, VLSP. They get challenge every year to promote the development of a language model for many domains like humanity, language, social science, and history. And those data sets are used to fine-tune LM model in many architecture. And on the left side, we have a lot of embedding like Herbert from Vin model of Vin AI. We have a good performance state of the art on some NLP tasks like post tagging or dependency tagging name entity. So, and we just have some a lot of Llama with extension of Llama 2 in hand on the 800 million tokens, and which have a good performance. It's exactly 50% on the per GPT. And here I just have talk about another chance in Vietnam regarding generative AI about the multimodal, multimedia generative AI. This is promising field in Vietnam. Why? Because we have the Association for Computer Vision, which is working both in university and in factory. So many companies like VinFuture or FPT AI or Computer in Vietnam, and many companies in Vietnam try to focus on some application in information extraction from the ID photos, medical analysis from X-ray image, face matching and face search, and vehicle recognition, and so on. So based on the application, so the researchers from university and the industry and company try to view some multimodal, generative AI. Especially that they focus on some models like vision encoder, LV and projector, and especially they develop on some type of Vietnamese many model like liquid model here, and which especially data sets from both multimedia and so on. And we also here in VNU we also develop some type of multimedia multimodal generic model. Here's for controlling the device to a smart camera here, and some other group in VNU so just focus on human machine interaction for paralyzed problems. Then the course ideas of all these architectures beyond the multimodal next gen architecture. I can see picture that we can capture in image and audio video to generate a projection of the own to a language model. And one of the things we just focus here is just AI on the edge, which links language model. And you'll see that one of the striking part here that is to say that we're using LLM for designing chip in this way instead of some complete LLM, which has used for one of the small versions of a language model for creating the LLMs. So we convert from the LLM to SLM. It means that we compute, we just use a small language model. We can efficiently decompose the problems to the chip design. And the next step is executing the AI operation with the GPU and SPC. And you can see that in Vietnam, there are so many big companies like Viettel, CMC, and everything here. So over there, so planning to deploy the AI operations, IAO, from a data operation and FPC center. So we aim to limit assist by integrating data from different sources in a central place and incorporating AI algorithms into the GPU and SPC to form the AI operations. So there's a lot of agentic benchmark like for GPT, for Whisper and Swift, for some type of text here, but it is based on the AI operation with the GPU and SPC. And we also have seen a large language model, but we're working with that because an image, but one like we work in our world. And so in this case, we have to integrate between the 3D dimension into the LLMs. So 3D LLM could take 3D representations and input, and it can handle both object and the scenes behind. So in order to make a more immersed, and so the kinds of 3D LLMs just applied to for generative scripts or sounds of computer graphics, and when we was applied in some companies, so you can see in the picture. For example, Eon Realty in Vietnam, or in some companies, they use the type of 3D LLMs. And lastly, most of the effort in Vietnam is coming for shadow AI and ethics. It means that the shadow AI, they have been aware of the using generative AI in their works often without the awareness of employer. So in Vietnam, we support our innovation program from Australia government. So the Ministry of Science and Technology in Vietnam has just issued a document regarding the guide to use the AI responsibility. So this means that whenever we try to make application of AI in Vietnam, we have to assure that they follow some type of criteria like technical safety, inequality, harmful mistake, and so on. I think that this is the way for guiding the how to use and how to utilize the AI correctly. Okay, and so that's what I just talked a bit about the development of generative AI in Vietnam. But in conclusion, I would like to emphasize what should be a focus in Vietnam for next 5 years. So in order to make a reality of generative AI in Vietnam, so we have to foster generative AI. We have to must have some AI centers we embedded with SPC and GPU to deploy some local LLM model. And in another way, we have to use the program engineering for the post testing for LLM to make avoid bias of the data sets and coping with AI ethics together with AI association framework. And one of the things we just forgot on, I think that will form next 3 years, we just focus on generative AI on chip with some style of small language model or lean language model in some domains. And in order to make an application in reality, we just have to enhance the multi-model, multimedia generative AI in applications with a powerful virtual agent, serving especially for government and industry. And lastly, I just have to emphasize, we need to set up a generative AI association. Yeah, we call Gaia. We will connect international and Vietnamese AI researcher to demonstrate the solution and new trend of generative AI within the university, industry, and the government. So that's all of my presentation. I am hoping that I just send some brief information about the development of generative AI in particular and AI in general in Vietnam to all of the attendees here, and wish to make a cooperation with Gen in the term of generative AI for now. So thank you so much. Thank you so much.
Thank you, Associate Professor Lei, for such insightful sharings. Now, to enrich our discussions, I would like to invite our esteemed panelists, Dr. Huang, Dr. Horvis, Dr. Ratner, and Associate Professor Lei, back to the virtual stage for a brief panel reflections. This will be a dedicated 5 minutes for them to share any concluding remarks or insight before we stepping into the highly anticipated Q&A session.
It was an exciting talk. Thank you so much for sharing. This is a great time for all of us to really look at the challenge and help to bring this amazing AI breakthrough to improve real application and services. Foundation model is great. It's just magic, can do almost everything. But that last mile, as Alex talked about, is really challenging. And 90% performance is not good enough. We need high quality, reliability, no hallucination. And that last mile takes a huge amount of effort to close. So I want to share 3 points. Number one, I can see the fourth industrial revolution is coming, but the productivity gain is yet to be proven. So that's up to all of us to work together to embrace AI and really bring that generative AI capability to the place that you need it. The analogy I want to talk about is today, it's almost like there's a steam engine invented in Britain. And people in the US, they need to travel across Atlantic to get that steam engine power, then come back to finish their work. That's not scalable. But that is what is happening. A lot of people, they stop what they do, they go to ChatGPT, they get an answer, they cut and paste, they come back. Even that whole process doesn't have the context of what is happening. So a simple prompt is not able to bring that broad context. So we need to really make sure when we embrace generative AI, the foundation model provided by whether it's Meta, Google, Anthropic, or OpenAI, they need to really have the right context or fine-tuning with the right high-quality data. So how to really get a cost-effective solution in the right place without traveling across Atlantic to get a steam engine power is the challenge facing all of us. So Professor Le talked about a lot of things like edge-based lean large language model. That is going to be one of the important pieces because on the edge, you have the sensors. You know what is going on, right? In the cloud, foundation model in the cloud, you can only send the prompt. That's limited. So how we can combine this edge and the cloud together is going to be a challenge. That's what we need to innovate with the federated approach. So there's just lots of opportunity is driving the adoption of generative AI. So I want to stop here. I really think all of you have this amazing experience and insight. Please share your reflection.
Yeah, maybe I'll just jump in. XD, thanks for those remarks. One thing we should be thinking about as the audience here and the panelists is that beyond the technical advances, we're talking very much technical, we're going to have to attend to what I like to call socio-technical considerations to nurture the creative and vibrant uses of these technologies, whether it be in science or applications, Zoom communications, in daily life. And these include efforts for, like to start with, to ensure, how do we ensure that scientists and engineers, let's go with my talk on science, how do we make sure that scientists and engineers have access to computing infrastructure, including the resources and tools and data sets? How do we make sure that as our young engineers and scientists and educators and people in all walks of life are growing up and being educated in our educational system, that they're actually getting the right kind of AI educational curricula, K through 12, through higher education, to work with these tools as common, as part of daily life. And then we didn't talk much about the important issues of prioritizing investments in safety and responsibility, thinking through as best we can, and taking proactive measures against potential misuse of the rising powers of AI. Now, I like to say that all great inventions, great innovations are dual use. These powers can be used to achieve wonders, and everybody today on the panel is talking about the wonders. But they also can cause harm, and sometimes via inadvertent, unplanned, and unexpected effects, other times via malevolent uses. So we have to be vigilant and do our best with considerations and mitigations of the downsides. By doing that, we can better harness the beauty and the wonders, and we can apply to human well-being and human flourishing, while minimizing the costly outcomes and abuses. And so I think we have to just be aware that with great power comes great responsibility.
I fully agree. I want to stick to my record of staying on time. So I'll just say a huge +1 to that, and great talks from everyone.
Professor Ler?
Yeah, I also agree with the point of view of Dr. Huang and also Eric, and I think that one of the best thing I see is a lot of advantage of generative AI to the community, and not only in the world but also in Vietnam right now. But I just have list a few disadvantages that we have to anticipate from now. It's just we have to cope with data bias. From the company database, from some type of chat, some type of application. So in order to do that, I have just make a suggestion to make a generative AI associations, Gaia. So if we think that is it possible that we can make some type of associations, it's good for not only one country but to all many countries in the world, especially in developing generative AI. We have in that type of association, we can define the term, we can define the terminology, we can define the protocols to use generative AI. Safely. Okay. So that's my point of view.
Okay. Thank you. Now I will end this reflection. I think VinFuture Foundation is going to really discuss the nomination process and the call for nomination. Is that right? Then we'll actually come back to have general Q&A.
A heartfelt thank you to all of our panelists for invaluable contributions today. While they take a well-deserved 5 minutes break, we invite you to watch a short video tutorial on how to submit nominations for the esteemed VinFuture Grand Prize. Keep an eye out for the video, and we will be back shortly just after 5 minutes to start the Q&A session.
Greetings from the VinFuture Prize. Please find instructions for the nominator following these steps. To begin, you can access the nomination portal at online.vinfutureprize.org/nomination. Or you can scan the QR code you see on the screen right now to open the nomination webpage. On this webpage, you can download the instructions and the endorsement letter template. In the instructions, you will find the complete nomination form, where you can draft the nomination whenever you have time. Then, you can copy and paste the draft into the online portal. Please click on Sign Up, and upon successful registration, you can simply use your ID and password to log in. After login, please click Nominate Now to start a new nomination form. Subsequently, you can see 7 content tabs on the nomination form. To begin the nomination process, on the first tab, please select the prize category as well as the type of nominee, whether it is an individual nominee or a group of nominees. Then click the Start button to proceed to the second tab. And we would like to call your attention to tab number 5 and tab number 7. On tab number 5, your evaluation, you're invited to give your evaluation of the nominee's invention, including its groundbreaking discovery, scientific fundamental knowledge, specific approach, uniqueness, and advancement. Then you are required to clarify if the invention can be transferred to a product and highlight its most significant socioeconomic impacts. This includes the number of beneficiaries, such as people, countries, and continents. Additionally, please explain how you believe this invention has or will potentially transform the everyday lives of millions, if not billions of people. Next, please provide information on the history of the invention, such as when and how it started, and who else, except the nominee or nominees, was involved in initiating or contributing to the invention. About tab number 7, supporting documentation and evidence. There are several important documents that the nomination portal and form require, and we would like to call your attention to 3 critical items. The first one is the CV of your nominee or the CVs of your group of nominees if you are nominating a group of people. The second important item is the endorsement letter. 3 endorsement letters or more are strongly encouraged, but 1 is mandatory. The third one is the additional form of nominees. Please be as specific as possible when providing the information. Additionally, you are strongly encouraged to include any valid intellectual properties, publications, patents, or other supporting documents that provide evidence for the nomination. Finally, after filling out and providing all the content in the 7 tabs, please click on the Submit button at the bottom of the page to submit your nomination. If you have any questions or you face any technical issues, please email us at secretariat@vinfutureprize.org. We will be more than happy to assist you in your nomination process. Thank you very much.
Before moving on to the most awaited Q&A sessions, I would like to make an important announcement from our side. The VinFuture Foundation has officially called for nominations for the 2025 VinFuture Grand Prize and 3 Special Prize. The nomination portal will be open until April 17, 2025. We hope to see you joining us in making a positive impact on humanity by nominating deserving technological innovations that have the power to change people's lives. And now is the moment you have been waiting for, the Q&A sessions. It's your chance to delve deeper into this topic with our esteemed panelists. Please feel free to actively participate using the raise hand functions. We'll unmute you for a direct exchange with our experts. And then for those who prefer a more indirect approach, you can simply type down your questions in the chat box, and we will make sure your question reach the most relevant panelists. Please don't hesitate. This is your opportunity to gain more valuable insights from our experts. It seems like I have the first questions from one of our audience, and I would like to invite Dr. Eric Horvitz to start the Q&A sessions with this one. Dr. Horvitz, you mentioned that advance for AI in the science can lead to new capabilities. How can these capabilities be misused, and what can we do to guide the technologies to good use? Dr. Horvitz, please.
Thanks for the question. Well, first of all, in using systems, AI systems in high stakes areas like decision making and diagnosis and healthcare, we have to be very cautious about subtle biases in the data sets that can lead to poorly understood biases in the predictions and recommendations that might be, for example, accurate for one demographic group or for males, but not for another group or females, for example. And we have to be careful about the bias in our society and leading to biases in our data sets, leading to biased performance of our systems. Always have to worry about privacy violations, privacy and civil liberties if data is being used without permission, without consent and disclosure, or proper anonymization. That's also a challenge. I mentioned a few seconds ago about dual use and weaponization of these technologies. AI can be exploited for malicious purposes. Already in the last few months, we're seeing, online calls with avatars that seem very realistic, that are impersonating decision makers and leading to poor outcomes. And so the understanding how to take this generative world, which makes it easy to generate synthetic media, synthetic visions of the world, makes it hard to discriminate real news stories from generated ones, and we have to sort of understand methods and come up with techniques for dealing with that. And we're working on them, including media provenance work. And then we might see economic disruption over time, where it's unclear how AI will be applied in ways that would enhance and the economy and sort of make new jobs and train people and retrain them versus lead to massive job displacement and economic inequality. So these things come to mind. I think that we actually am optimistic about both about us guiding in the technology with ethical frameworks, with technical advances, red teaming, transparency, regulation and oversight. We're seeing lots of efforts on that front. Public engagement, so we have more multi-party stakeholder comments to shape the technology, and sort of collaborating across sectors, across disciplines, where AI developers can work with policymakers, with stakeholders, having public discussions, and so on.
Thank you, Dr. Horvitz. And now I would like to invite Associate Professor Ngô Quỳnh Thư from Hanoi University of Science and Technology to unmute and directly exchange information with our panelists.
The way to train AI is very important, and I'm very interested at the way you train AI in your work. For example, as I understand, I think that you are training your AI according to LLM models, right? It means that you use language model for training AI mechanism. So it means that your AI will be able to answer the question with very beautiful way of language. Is it right?
Yeah, I could. Yeah, and I could take a step back, and this is very far from just our model. So it's more, we're a tool, and the academic work we've done is part of the tool chain of building the data for tuning and training these models. A small part, right? But I think in general, there's a lot of the folks are kind of viewing this in two major phases: the pre-training and the post-training. That's kind of one grouping that I've heard more frequently, and the pre-training is very general. It's lots of learning from many data sources against generic objectives, as simple as roughly look at the first K words or 10 words and predict the next 10 words. And if you do that over large corpuses, then you can learn surprisingly generalizable models and skills. Although to Dr. Horvitz's point, which I could probably guess I would like, you can also inherit the biases of the distribution of said data, which is a whole separate thorny and interesting issue. And then there's the post-training phase, and that's where a lot of our work is, where you're teaching and tuning the model, updating some of its weights perhaps through tuning to be better at a specific skill. So maybe you want it to be much better at oncology or fraud transaction surveillance. And that's where you give it lots of specific examples in a certain domain for what you want it to do. Just like you'd kind of train a college student to do a specialized task with lots of instruction and concrete examples. So in both phases, data is very important to the training, and but I think that's the general kind of way it's broken down, and we focus a lot on the latter. So hopefully that helps a little bit. I'm not sure if I perfectly addressed the question, but I was just going to give a quick example, which I can share briefly. We've done some work with an e-commerce company in the US called Wayfair, and they actually presented this at the Google Next conference recently. So this is public. But it's kind of a simple example that gets to your point that you just made about domain specificity. We took a base multimodal AI model, text and image, and we just curated down the data to be specific to their domain of interest, namely furniture. A lot of tooling and work went into shaping that and curating that distribution of data, but the result was a roughly 56-point accuracy gain on the tasks in that domain. So a very intuitive point. If you shape the data to be more domain specific at all stages of training, you can improve performance quite a bit, which is perhaps super unsurprising, but it's, I think, an underappreciated set of approaches. And I think that is exactly your point about, domain specificity, or one example of that, if I just wanted to throw that in.
Okay, thank you.
So the next questions is for Dr. Xuedong Huang. Can you please share with me what should be the directions for AI research in developing countries like Vietnam? This is a question from Mrs. Hong Chen, MD of TMA Innovations.
Yeah, I don't think I can give that suggestion. Every country is different, and I was very impressed with what Professor Le talked about in Vietnam. And there's a wide range of activities going on. I'm also, as a VinFuture Prize Council member, I have been visiting Vietnam in the last 3 years. I'm very impressed with what is happening. For example, the healthcare system, VinBrain, VinAI organizations, they have pushed a lot of frontier. So it's fantastic. For Vietnam, I think the first thing I would address is the language barrier. And if you look at the quality of 3 foundation models, closed source, they are Gemini from Google, Cloud from Anthropic, and the GPT from OpenAI. They support roughly 200 languages, but the best quality is English. That is the reality, because the amount of data all 3 companies use to train the foundation model has been dominated by English. So you can see many countries, they are taking the local data, trying to further improve, but they cannot customize those 3 closed source models. So what they did was, everyone actually, there's actually common pattern. They take either Mistral from France or Meta's Llama. Now they have Llama 3.1. That is amazing what they have done, and Meta. So it's open source. Apple also open source, not only their own model, but also the training data set. I can see the pattern, whether it's in Abu Dhabi or in Beijing or in Vietnam. And Chinese companies, they are just taking the open source model, customized for improved Chinese version. And Arabic is actually being done in Abu Dhabi, really just in pushing the frontier of the quality of Arabic. And in Vietnam, the same pattern. So no matter where you go, you can see that many countries, from Japan to China to Vietnam, they all focus on improving their own language. When you have the good foundation model for the language, then magic happens, right? Whether it's customer support or personalized education or meeting summary, like what Zoom is doing. We support roughly only 7, but the rest of the 30 languages are not as high quality as we want it to be, because the foundation model we massage are from OpenAI, Anthropic, and Gemini. So that is the first bit for Vietnam. The second one, I really like the edge-based solution. There are a lot of scenarios. Also, in many developing nations, the networking is not as fast or reliable as we want it to be. So if you can really have a powerful device that is coming, and a lot of things can be done on the edge. So Apple introduced their AI powered iPhone. Microsoft is working with PC vendors from HP to others. Actually, I participated in HP's AI PC launch event in New York. So HP is pushing out the most powerful AI PC with amazing capability. A lot of things that used to take a lot of resources, like speech translation, and it can be done completely on the device. So essentially, you can speak 7 languages, and magically you can translate all of them into the language you want. So you don't need a cloud connection. Just think about it, 5 years ago, speech recognition or machine translation consumed a large chunk of the server resources. Now everything can be done on the edge, even without the language identification. No matter if you are speaking Spanish, Portuguese, or Japanese, doesn't matter. The system can recognize all of them simultaneously. So the edge, I would say, is a great opportunity for countries like Vietnam. Then education and healthcare, I see a lot of activities already happening. So just it's amazing. It's almost like the small mirror of what is happening in the US. Everything, what I know of in the US, you can find a counterpart in Vietnam. That speaks for the creative work and innovation and the push from many colleagues in Vietnam. As you should all be proud of what you have done.
Thank you, Dr. Huang. And we receive we will receive live questions from Dr. Ray Bunton from Vin University. Doctor, can you unmute yourself, turn on the camera, and go live to discuss with Dr. Eric Horvis, please?
Before I say, just want to point out, I really loved your talk, Le Huang Son. I hope we can hear more of that. That was fascinating about what's going on here in Vietnam. Eric, so we're looking at translation here, largely in the medical area, which is there's a big need in teaching for medical specialists and nurses. So the question is about, we get the impression that these large language models are getting pretty good at translation. They're not, in our tests, they're not quite up there yet, but I just figure they've got to replace. Also, when we ask a complex medical question to a large language model, it appears, well, ChatGPT-4 anyway, it looks like it's translated it internally to English, answered it, and then translated the answer back in Vietnamese. So in working with the models in Vietnamese, it's almost as if it's translated to English internally. But just hearing your views on this, are these things going to replace, our lovely sort of translate apps that we all use these days?
So let me just say that back to XD's comment about lots of the training intensity is around English corpora. As to what goes on with translation in and out of English, these are interesting research questions. I don't think it's well understood yet. I would strongly refer you to an article by Robert West at EPFL, who has looked at the identifying what happens at the layer of levels in these neural net representations with German